Hello everyone, this is Sonu from the Pranil Academy. So today in this video I am going to start a new series on the graph data structure, and after the completion of this playlist I will be uploading a lot of videos on the algorithmic problems like dynamic programming, greedy technique, and some other advanced data structures like segment disjoint sets, and I will solve a lot of problems based upon these data structures. So guys, let us start first the graph in this video. So what exactly is the graph? So graph is the nothing but the collection of the edges and vertices. So what are the edges and what are the vertices here? So I have drawn some circles here. Let's see here in the diagram. You can see that I have already drawn some node like this circle. You can make it, the name is make it name 1 2 3, this is 4, and this is 5. So here this 1 2 3 4 5, these are called nodes as well as vertices. And what are the edges here? Edges here, if the node 1 is connected to node 2, then we say that there exists an edge between the node 1 and 2. If node 2 is connected to node 4, then we say that node 2 is connected to node 4. If there exists a edge between node 5 and 3, then we say that node 5 and 3 are connected and there is a edge between these two nodes. If the node 1 and 3 are connected, then there will be a node from 1 and 4, and we say that there exists an edge. So the graph is what actually is the collection of the vertices and edges. So what are the vertices? Here vertices are, if we see that vertices are 1 2 3 4 5, right? And what are the edges here? Edges are, if we see that here the node 1 and 2 is connected, so there is a edge between them. Node 2 and 4 is connected, so there is a edge between them. And node 3 and 5 is connected, so there is a edge between them. And again, if we say about the node 1 and 4, which is also connected. So here the how many edges are there here? If we see that how many edges are here, 1 2 3, that is a 3 and 4. So here we have 4 edges and 5 vertices. So this representation is also called the edge list representation of the graph. And also there are various representation we will see in the next videos, and that is the adjacency list, adjacency matrix, and why we prefer generally adjacency list over the adjacency matrix. We will see all about the comparisons, and we will finally solve other problems with the help of the adjacency list. So don't worry guys about the name of this adjacency list or matrix. I will be discussing in detail in the next videos. So today just understand that what is graph. Graph is nothing but the collection of the vertices and edges. What is vertices? Vertices is if you are representing some nodes, and we have already named it 1 2 3 4 5 6 and something, or instead of integer you can make the name of this node as characters, that is A B C D, some other things. You can take any name. And if the node is connected, then there is an edge between them, and all the collection of the edges, here is the edge, and all the collection of the vertices, that is called the vertex set. So right, so here this is the vertices and this is the edge set. So graph is nothing but the collection of edges and vertices. But why do we need the graph data structure actually? Because there are a lot of real life problems which are required to represent the data for it with the help of the graph. That is, if we talk about the Facebook, because not only Facebook, any social media data, Facebook, LinkedIn. So just consider example of the Facebook, like let's say the user 1 here, user 2 here is there, user 3 is there, user 4 is there, user 5 is there. So let's say the user 1 has sent the friend request to user 2. If the user 2 has accepted the request, then there will be an edge, because there is a direct connection between the user 1 and user 2. if the user 2 has sent the request to user 5, then if the 5 is accepting the request of 2, then there must be an edge between 2 and 5, that is a direct connection between the edge 2 and 5. If similarly, if 5 and 3 are connected, then there will be a direct edge. If 1 and 5 will be connected, then there will be a direct edge. Similarly, 4 and 5 are between them, and similarly let's say 2 and 3, just I am assuming, because there all the users are connected randomly. There is no any sequence or order that why the user 1 is connected to only 5 and 2. No, they are connected randomly, right? So here is the connection. So at each user we can treat as a vertices, here vertices or node, because this is also called node. So here all the users we can treat like, and this is the vertices. This is one vertex, this is the another vertex, this is the another vertex, and this is the another vertex, this is another vertex. So here each user is treated as a vertex, and their connection is treated as a edges. So here if we see about the edge, what is the edge set? Edge set will be the pair in users in the pair. It is 1 2 2 3 3 5 2 5 and 4 5. So what will be so how many total number of edges here? 1 2 3 4 5 6, and so here total number of edges will be 6, and total number of vertices is here 5. So here the all the vertices vertex point the user is present, and their mutual their connection is the edge is between the two users. So like this kind of data is stored by the graph data structure. The same thing happened to the link list, some Instagrams and some other social media platforms, right? So this is the how Facebook is using the graph, and the best part is about the this Facebook using graph is because the graph we will see in the next videos that a graph can be stored in the form of matrix, and on matrix we know that this is the part of the mathematics, and we will apply a lot of statistics, linear algebra, to know about the proper trend in how the users are connected to each other, and how one user is most clicking the ad and some other stuffs. So this is really grateful technique to the Facebook and some other social media sites as well. So if we consider some other applications, like everyone is using the Google Map, and if you are trying to visit some other city from a unknown city to unknown places to unknown places, like let's say if you are first time visiting the Delhi, and if you want to go from the Calcutta, so there will be a lot of road networks from Delhi to Calcutta, but you don't know that which should I choose. But if you try to take the help of the Google Map, this will tell you the shortest path, that if you pick this path, then you will have the shortest time to go through Delhi to Calcutta. So like this Google Map is also using the graph, and also it is using the shortest path algorithms. I will be discussing in very detail in the next coming videos that shortest path from the one node to between two nodes, and I will discuss shortest path from one node to all the other nodes available in the network. So we can say that the graph is widely used in the road network. Like if you see that there is a city 1, city 2, if here is a city 3, city 4, city 5, city 6, city 7, city 8. So if we say that city 1 2 is connected, 2 3 is connected, 3 4 is connected, and this one is connected, like this one is connected, again this one is connected, here is this is connected. So if we say that this is connected mutually and this is connected mutually, so we can say that this is the separate island. This is the separate island, and this is a bigger network of the city. So we can say that all the nodes in a graph may be connected to each other or may not be connected to each other. So if we see that all the nodes are connected to each other, that is there exists a path from one node to other nodes directly or indirectly. So in that case we say that the graph is connected. If the direct path or indirect path does not exist, that is we can't visit from one node to other node, then we say that the graph is not connected, that is the disconnected. And we say that this is the separate components of the graph. This is the component 1 and this is the component 2. We will see in later videos that how we do all the steps related with the connected and disconnected components of the graph, right? So we said that this is the connected components, this is the another connected components, and this is the two parts of the graph. So like this there are a lot of real life applications of the graph data structure. And if we see some other important applications like in routing algorithms, because if you are from computer science, then we must have read about the routing algorithms which is used in the networking. So places the graph theory is widely used. And also if we talk about the school vans which is visiting to the all the houses of the students, and the driver will try to pick a path such that it has less time, it should take the less time to visit all the houses. Also the vendor cars is using the a concept of the graph data structure. So like this there are various applications. Also from the next videos I will be discussing that how we can represent graph in some different forms, and also I will write code and will show you that this is the method that we will use in the next problems that we will solve in the next coming session. So thank you for watching.